All right, let's dive into a piece of technology that seriously feels like it's straight out of science fiction: 3D printing. We're going to go on a quick journey today from a simple idea, a digital file on a computer, to an actual physical object that you can hold in your hands. It's pretty amazing. Let's get into it. So, I want you to just think about this for a second. What if you could download a physical object? I mean, really. Imagine you need a new phone case or a weird little part for your dishwasher breaks. Instead of ordering it and waiting for days, you just download the file and print it out right there. That is the incredible, revolutionary idea that's at the very heart of 3D printing. Okay, so to really wrap our heads around how this all works, here's the plan. We're going to start with the basic concept, then walk through the actual process. After that, we'll look at the tools involved, see how it's being used in the real world, and then we'll finish up with a little reality check. First up, let's break down what makes this a totally new way to create things. I mean, fundamentally different. So the official fancy term for 3D printing is additive manufacturing. And you know what? That name tells you basically everything you need to know. The key word there is additive. It's all about building something up from absolutely nothing, adding one super thin layer on top of another. Now, this is the complete opposite of how we've made things for centuries. We've always used subtractive manufacturing. Think about a sculptor with a big block of marble. They start with a whole block and chip away. They subtract material until the statue is left. Additive manufacturing just flips that whole idea on its head. You start with nothing and add material only where it's needed. And as you can imagine, that saves a ton of waste. Okay, so we get the main idea, building layer by layer. But how does an idea on a screen actually, become a real thing? Well, it all boils down to 3 key steps. And it's actually a pretty straightforward process when you break it down. First, you need a blueprint, right? A digital 3D model. Then some really clever software acts like a digital deli slicer, cutting that 3D model into hundreds, sometimes thousands, of paper-thin horizontal layers. Finally, the printer gets to work. It reads that sliced file and just builds the object, one meticulous layer at a time, from the bottom all the way to the top. All right, so we know the process, but let's take a quick peek under the hood. What are these printers actually using to build all this cool stuff? So this table gives you a quick look at the 3 most common types. You've got FDM, which is probably the one you've seen the most. You can basically think of it as a really precise robotic hot glue gun that melts and draws with plastic. Then there's SLA, which is just wild. It uses a UV light to harden liquid resin, literally pulling a solid object out of a vat of goo. And finally, you have SLS, which uses a high-powered laser to fuse tiny particles of powder together. Each one has its own strengths for different kinds of jobs. And believe me, the versatility doesn't stop there. We are way beyond just simple plastics at this point. These printers can work with incredibly detailed resins, industrial-grade metals like titanium and steel, and even really advanced stuff like carbon fiber composites and biomaterials for medical uses. The list of what we can print with is just growing every single day. So, with all this tech and all these materials, what are we actually doing with it? This is where it gets really exciting. Let's look at the impact this is having out in the real world. I mean, the applications are just staggering. In healthcare, we're talking custom-fit prosthetics that are perfectly tailored to a single person. In the aerospace industry, they're creating these incredibly complex, lightweight parts for jet engines that were literally impossible to make before. People are even experimenting with printing entire houses. From manufacturing to fashion, this technology is popping up everywhere. When you boil it all down, the real power here isn't just about making stuff. It's about making highly complex, totally customized things whenever you need them, on demand. This is a huge shift away from mass production toward what you might call mass customization. It could completely change supply chains, letting us make things much closer to where they're actually needed. Now, as incredible as all this sounds, it's not some magic bullet for everything. At least, not yet. So to get the whole picture, we need to take a quick, honest look at both the good and the bad. So on the one hand, the advantages are massive for certain things. It's perfect for making one-off prototypes quickly and cheaply, and it lets designers create shapes that are just impossible with any other method. But on the flip side, it's still way slower than mass production. You're not going to 3D print a million plastic forks, for instance. For some applications, the material strength isn't quite there yet, and the cost to get a really high-end industrial machine is still pretty steep. But even with those current limitations, the direction this is all heading is crystal clear. The future of how we make things is, without a doubt, additive. This is a fundamental change in how we think about designing and producing, well, everything. And that, really, brings us to the most important question of all. As this tech gets better and cheaper, we're moving past the point of asking, what can we print? And we're starting to have to ask, what should we print? And that question, it pushes us to think beyond just the technical stuff and to start considering the creative and even the ethical possibilities. So what's next? Well, that's up to all of us to figure out.